So let's rock and roll. So let's start by a quick little review about what we've been learning about recently. So this is where I would love some audio comments, or I'd love some stuff in the chat. What have we been talking about in this module so far? Especially because we have a couple of new students, maybe they would benefit from understanding like what we have been talking about so far. So pop your hand up if you're willing to give a comment, or you can tell in the chat. So Mbali and Zanele have said the sine rule is something that we've spoken about. And Keisha has said we spoke about the area rule. And Morgan has given us the formula for the area rule, which is fantastic, which was basically the area rule was a half. Well, there's different ways of writing it, but one of the ways you wrote it was like that. And then the sine rule was often written like,
recording in progress.
Like and can anybody tell me what we did? I suppose the area rule is kind of explanatory. It finds the area of a triangle, but what did we use the sine rule to help us do? What was the so here we go. Naomi has said we use the sine rule to find either angles, or we use the sine rule to find sides. Absolutely. And the area rule, we used it to find kind of the area. And actually, it was also possible to find angles and sides, but in sort of a less direct way. The main focus was area. Okay, and the big thing that this module is about is that these two rules work in all triangles. They don't just work in right angle triangles, they work in all triangles. And that was the big change from grade 10 to grade 11, where trig triangles were really very focused on right angle triangles, whereas now we deal with all triangles. Okay, now tonight's lesson is going to be based around the cos rule, or some teachers say the cosine rule. And so I'm going to start with that shortly. Okay. So let's start with this situation where we label or we draw a triangle. And when we draw a triangle, there are some basic conventions. The first one is we tend to call the corners by big letters, and we tend to call the sides opposite those big letters by the lowercase names. Okay. Now, what does the cos rule actually say? So the cos rule is always going to be it's always going to be used in the case where we have two sides and the included angle. So what does it mean when I say two sides? Well, and the included angle. So this is one side, and this is, I'll call this side, excuse me, side B. And here's another side. We'll call this side C. Now, we could have called it the side AB, but it takes longer if we do it like that. So we're just going to use the little letter. Now, the included angle between those two sides is the angle between the two sides. And that is going to be angle A. So this is what the cos rule says. It says, if you have two sides on the included angle, you can find the third side of the triangle. So how would we write this? And it looks a little bit like Pythagoras, because Pythagoras has squares in it. So we start by going a squared is equal to b squared plus c squared. And if I just left it like that, it almost looks exactly the same as Pythagoras, but we're not done. What we do after doing that, and notice how the b is the side I was looking at when I started, the c was the side I was looking at when I started. I then write 2 times 2 values, and then I times that by the cos of the angle in between those two sides. So what I'm going to do here is I'm going to put a B and a C, and then over here, I'm going to put a A. Now that looks a bit weird, but I'm going to go over it again just so that you get a feel for it. So if I want to find, or the cos rule says that this relationship exists, that if I want a side, I can write that side by saying a squared is equal to the other side squared plus another side squared minus 2 times those two original sides we were looking at times the cos of the angle in between. Okay, now that is a bit of a mouthful to start with, but you'll see by the end of this lesson, it's actually very easy to use. But I just want to give you a chance for a vote now. Give me a thumbs up if the basic idea of the cos rule, as I've described it here, makes sense. You don't have to know how to use it yet, just that you understand that if I've got two sides and an included angle, there's a formula I can use to get the third side. That's all I want to kind of establish. And then I'm going to take it out and use it in, and if you don't understand yet, I'm totally not worried. I'm going to show you how to use it. Okay, so here is example number 1. I am given a triangle, and I'm given two sides and the included angle. So what are my two sides? The one side is here, and that's 23 centimeters. And then I have another side, which is here. Before I go and work this out using the cos rule, why can't I use the sine rule? For those who were here before, why can't I use the sine rule? Because I mean, like, let's rather use the tools that we already have before we branch out to new tools. What's the problem with trying to use the sine rule? I'd love a comment or a statement by someone about, or should I use the sine rule to solve for the unknown thing BC? So Mbali and Zanele have said we are given two sides. That's true, Mbali, but we also were given two sides and an angle in previous questions. So what's special about this? So all sizes are below 90. We don't have two angles. That's true. But there's something else that's missing. What we don't have are pairs of angles and sides that are facing each other. So when we did the sine rule, we always had we would have an angle, but then we'd have a side opposite that angle that gave us a value. Whereas if you look at this, the way it's written, we have a side, but we don't have this angle. We have another side and we don't have that angle. And so we can't make the matching pairs that we made. And for those who are new, you'll see the video. We made these pairs when we used the sine rule. And we don't have an angle and a side opposite each other to help us. We only have two sides and the included angle. That's why we need a new tool for the job. The sine rule just wouldn't cut it. So let's use the idea that I was showing you before. So if you want the third side, what I'm going to write is I'm going to write this as BC squared. And what I'm going to suggest is that in the space, I'm going to leave spaces. Well, let me zoom in a little bit here. So I said something squared plus something squared minus 2 times something. I know there's a lot of somethings. And then the cos of something over there. So I want to know, what do you think goes over here? And what do you think goes over here? Based on the example I showed you previously. Oh, I see someone's hand is up. Maybe they can help us. Maseko, what do you think goes in the blue and red spots here when using the cos rule?
Hello, sir. So,
hey,
according to my understanding, I wrote BC squared is equal to 23 squared plus 20 squared minus
perfect
2 times 23 times 20 cos 55.
Nailed it. Love it. Thank you so much, Maseko. So if we look at this, all I'm doing is I'm saying, look, there's my one side, there's my other side. And at this stage, it looks a bit like Pythagoras. And then the exciting stuff that gives us the cos rule is just minus 2 times those other two sides times the cos of the angle in between. Now, what I want you to do is I want you to type this into your calculator, but I want you to give me a value for BC. And this is for everyone, huh? So I want you to try and use your calculator. I can also bring my calculator up on screen if that's helpful. So let me do that. I'm going to share I'll bring my calculator along for the ride. And I want to see, can you get BC by yourself? And I'm going to sort of show you what I'm doing on the, let you go first, and then I'll do my thing. So try and find. So maybe I should even write BC squared first before I write BC. So this is going to be 309. Da, 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 da. Now, there's a trick. Let's see what people are putting in the chat here. What are people getting for their values? We have to square root it. Yes, you do have to square root it to get BC by itself. Now, I'm going to show you a trick. I am not going to type this whole thing in again. My calculator has this value stored in the answer key. So whenever I press equals, the answer key holds the last value you have. So what I'm going to do is I'm going to click AC. I'm then going to click square root and then click answer. And what you'll notice is that the value that was stored was this without all the messy decimals. And that saved me so much time because now I can see I get 20,03 centimeters. And not all students know how to use, is that correct? 401, it is correct, yeah. So why are we getting, we should get 20,03, which is a bit of a strange one, but that is what the maths is saying at this stage. So this is just our first example. And so I wanted to just show you how you can use your calculator skillfully. And I also wanted to show you this. Give me a thumbs up if you followed the process and you're ready for another example. Give me a thumbs down if you're feeling a bit lost. Can we maybe hit mute all, I think, here, just so we have a clear thing other than me, and then we'll unmute as we go. Okay. Cool. All right, let's put this to the test now. So we've learned this new cos rule thing. We need to get better at applying it. And I want to ask you to try and go by yourself, to fly solo, to find me the length of QR. Okay. And then I would love some questions if you have any, and then we'll unmute you. Okay. Ask yourself what you need to start with. I would start by writing QR squared, and then from there, it's up to you. And then, let's see how it goes. Yeah. So something squared plus something squared minus 2 times this times the cos of something. And I'm going to say that's that. And then the cos is 67. So what I'm going to do is I'm going to go 3 squared plus 9.2 squared minus 2 times 9.2 times cos 67. And I get that. But now remember, that isn't my final answer. What I still need to do is I need to get QR. At the moment, this is QR squared. And what I'm going to do is, I know this is still stored in my answer. Oh, I hope maybe it isn't what's in the answer. Oh, it's still there. Yeah, good news. So I go square root answer, and I get QR is 8.49 centimeters. Now, if there's no squared here, because in this case, we're not finding area, we're finding a distance. And so this distance is going to be 8.49. Are there any questions or comments that students want to make? Now is a good time to ask questions. Are you, especially if you're not seeing how I'm laying this out? Otherwise, we'll go on to do another example. But yeah. Let's go to Khotso. Khotso, what's your question?
Sir, I would like to understand the formula that you use to calculate the grade.
So what I'm going to do is while we talk, I'm going to put this question up so that the students who want to continue can, and then let's have a conversation. So where am I losing you in the formula?
From the -2 upwards until the cos of the degree.
Perfect. Okay, here's how you do it. Whenever you see a side that you're trying to find, and you notice that you're given two sides and the angle in between these two sides, then you're going to go into cos rule mode, and you're going to start by writing down the side that you want to find. So I write down QR. Now, the way the cos rule works is the side you're trying to find is always going to have a squared. Then what I do is I write, there's going to be something squared plus another something squared. Now, that's something I'll show you soon. Then I have a minus, a 2. Then I have 2 more brackets that are going to be filled in. And then I have a cos of an angle. Are you okay with that bit?
I would like to understand where does the 2 come from, -2?
Okay. Good question. The place it comes from is the proof of the cos rule. And I'm not going to be talking about the proof today, okay? But basically what the cos rule proof involves is it involves creating a height of the triangle. And the height of the triangle is then used to prove the cos rule. But right now, so I'm not going to go into the whole proof because that's a separate lesson all by itself. All we're focusing on today is how to use the cos rule. Okay. So just for today, we're going to focus on the structure we use, and then like explaining why it works is a little bit harder of a question. Okay.
Okay, sir.
Cool. But thank you for your question. But you basically for today, you want to just get used to using this piece over here. Cool. Okay. So how are we doing on the answer for QR? I guess we should start by doing what I said. Here I should write QR squared. Well, I suppose I could just use the thing I've got above because it actually literally is a QR. So I can go 13. And I can go 4. And then 13 and 4. And then 70. And now what I need to do is I need to type this into my calculator. So I go 13 squared plus 4 squared minus 2 times 13 times 4 times cos 70. And that will give me what QR squared is equal to, but I'm not after QR squared. What I'm after is QR. And so QR is going to be, so I'm going to go AC, I'm going to go square root answer, and I should get 12.22 centimeters. This is not an area. What this works out is the length of this side over here. Give me a thumbs up if you, again, so Khotso asked a very good question. Like, why does this even work? And the reason it works, I can show you that through a proof, but the focus of today's lesson initially is just learning that if you have two sides and the included angle, you can actually work out the third side. And how do we actually do that? What's the process? And so that's going to be the focus. But I agree, it's a little bit of a mathematical mystery, isn't it? And so that's something which we can talk about in future. Okay. All right. Well, you know how I like a good multiple choice question. So let's do this multiple choice question. Tell me what you think the answer to this multiple choice question is. And hint, hint, you might need to use a tool that you learned how to use today. Oh, don't worry about the significant figures thing. I'm not going to worry about that. It's a different type of idea. Just worry about the length of AC to 3 decimal places. So what do we have? We want and then this is going to be 1.7. What are we going to do? We're going to say 1.7. Notice how the squared button comes in quite useful when you're using doing the cos rule, because there's so many squares. And then we're going to go square root answer 3.096 is what I get. Is there an option that goes with 3.096? So, okay, so they're doing with it would be C, although I can see why some of you would also say B could be essentially the same. It's just about a rounding issue. But both of these would be correct. That would just be rounded to 2 decimal, that would be 3. Okay. That's looking okay to me. I think we can squeeze in one more before we have a break. So here is your next multiple choice question. I'll blow it up in a second, just so that you can see the whole thing. Which of the following is a correct equation based on the diagram on the right? And now it's starting to get a little bit more exciting. And so ask yourself what you think fits the question. And I would love, if anybody's got a question they want to raise their hands for, you can go ahead and do that. That's one of the cool things about Watobe. There's always space for questions in the chat or in the over audio. So what am I trying to find? I'm trying to find the X, I guess. Well, who knows? I actually have to look at the options. Is it this one starts at 51, but that doesn't seem like it would be right. Because 51, yeah. So what do we have? It feels like if I wrote it out, the cos rule, that would be it. Now, this one doesn't fit because there's no 2 in front. And that one, the X, feels like it got lost. And so if I look at my option here, then option C is indeed the correct answer. Okay. Well, I think we've done a good job of getting to the grips with the basics of the cos rule. And I just want to reinforce again, we only use this tool in a specific, well, we use this tool when it's appropriate. But the one I want you to focus on is, again, we have two sides. So they're my two sides. And we have the angle in between those two sides. If we had a different combination of information, it might make more sense to use the sine rule. But in this case, if you want a third side given this information, the cos rule is your friend. Okay, it is time for a break. So make sure those cameras are on. And I want you to join me in standing up. And even if you don't feel, if you feel cold and lazy, I totally can be there with you, but we're going to do what we know is good for our learning. And so stand up with me and just be silly for a second. Okay. Oh, all right. Let's swing our arms and let's just loosen up. And while we're swinging our arms, we're looking away into the distance to give our eyes a break. And then we're going to roll our shoulders. And again, while we're doing this, we're looking far away into the distance so that we can give our eyes a break. And we roll our shoulders forward. Okay. Shake it out again. Then let's stretch the arms across. Oh, my shirt's getting tight. Maybe I'm just eating too much. Who knows? So there we go. One. And then let's stretch to the other side. Okay. And then let's shake it out again. And then let's go. Let's do a neck stretch. So just let your neck stretch to the one side. Nice loose sort of feeling here. And then the other side. You should feel a little bit of a tension there. Oh, I can hear good clicks going on. Okay, so we do that. Let's take 3 deep breaths.
I'm sorry.
Another deep breath. One more. Okay, and then let's just get our heart rates up. We are going to do air skipping again, and we're going to do 30 air skips. Okay, and we'll start in 3, 2, 1. Let's go. 1, 2, 3. Halfway. And have a seat. Cool. Let us know in the chat if you feel like your brain has benefited. Let me see in the chat if you're like, that was a waste of time. I don't mind either way. I just want, I'm just always interested to see how it feels on your side. And then while we do that, here is your brain puzzle for today. Cool, Cesar. I'm so glad that you feel like that. I feel like that after jumping up and down a bit. I always find my brain is happy with me. And you want to take care of your brain because the brain's important. Jeje, I see your hand is raised. Can we unmute? And then while that's happening, see if you can figure out the answer to this puzzle problem. Or maybe that was a hand that went up by mistake. I'm not sure. Maybe Kia can. What do we think the answer to this is going to be? I think 1 or 21 years. Okay, so what I think is happening here, is if we think of 4 squared is 16, and 7 squared is normally 49. Now, obviously, there's been some sort of pattern going on. 11 squared is normally 121. And what it looks like to me is that they're just taking the last digit each time. And so I think I would go with 1, unless there's another pattern that I haven't noticed. It feels to me like the idea is that you find the number and then you just take the digit that's in the units column. But maybe there's something else I've missed. let's unmute. I see there's some definite feedback there. Let's go to Tete. I'm asking you to unmute. Can you unmute, Tete? Or maybe your hand's up by mistake. I don't know. Can you hear me?
Yes, sir.
Hey, what's your thoughts on this?
Sorry, I just hopped on right now and I was wondering if you could recap on the things we've just done.
Okay, no, we'll do that now. So we're going to start with the second part of the lesson in a moment. We're just having a little half-time break. So we'll get going shortly. Cool.
Okay.
And Khonso, what is your question?
Sir, I think I see another pattern on this thing.
Go ahead and tell me. I'm interested.
1 plus 3 equals to 4, and 4 plus 2 equals to 6, and 6 plus 3 equals to 9. So my thought is that 9 plus 2 will be equals to 11. And I think that will be my answer.
All right. So you're right. There is actually more than one pattern here. And so I think, what would your next one be there then? So you're saying,
11.
so 4 plus 2 is 6. Oh, I see what you mean. And then you would have, so what do you have here? 2 plus 2 is 4. 4 plus 2 is 6. 7 plus 2. Oh, so this would be 13. Is that what you were thinking? Ah, I see
No,
that.
sir, I was looking at the end, not the first ones. I was looking at the products. I was saying 1 plus 4 equals 1 plus 3 equals to 4. 4 plus 2 equals to 6. And 6 plus 3, it will be 9. So in my thought, 9 plus 2 will be equals to 11.
11. Okay. So clearly there were a couple of different options here. So far we've had 11, 1, and 13. And I think for today, because we're just doing a little bit of a fun puzzle, I'm going to declare them all reasonable as answers. So well done to all of you who got 1, 11, or 13. Okay, let's go back to the lesson. And what I want to do is I want to continue along this idea that we were talking about. And so for students who have just come online, maybe have missed the beginning of this, so I'm going to give everybody a chance to try and figure out which of these 4 options is correct. And then we're going to go from there. So let's see if you can get the answer. For those who are completely halfway through the lesson, you might want to go back and watch the recording bit, but basically we're going to use the cos rule here because we have 2 sides and the included angle between those sides. And the way the cos rule works is going to be that b squared, the other side that we haven't involved so far, which is this bit over here, b squared is going to be equal to this squared plus this squared. And we're going to take those sides that we've got here. So that's going to be a 9. This is going to be a 7. That's going to be a 9, 7. And then the angle in between is 100. Now, of these 4 options, one of them is going to be correct. And we need to try and figure out which one is the one we think is the most correct. So this is where our calculator might be helpful. I'm guessing that that's 81. I would use my calculator for this, and this is 49. And this is going to be, so we've got 81 plus 49. What do we get? I think we're going to get 130 there. So, yes, we will 130. So we've got b squared is 130 minus, now 2 times 9 times 7. What do we get for that? 2 times 9 times 7. That is going to be 126. So we get minus 126. And then this is going to be cos of 100. But we want b by itself. So we have to square root that. And is there an option that matches that one? I think the one that matches for me is B, unless I've missed something. No, it's not that. It's not going to be that. Now, notice how there was a little bit of a kind of a false clue. The 34 is not involved in this one, because when you use the cos rule, you use the two sides and the included angle between those two sides. Okay, so watch out, because that was a little bit of a distraction for you. Okay, let's go from here. Let's try another one. See if you can work out the correct option for this multiple choice question using the cos rule as you've learned about it so far in today's lesson. Oh, sorry, that's a bit too small. Go ahead. And then while you're working on that, let me go to Cheche. What is your question, Cheche? Or I'm not sure if I'm pronouncing it right, if it's but yeah. Can you hear me?
Yes, sir.
Hey, what can I do to help?
I'm still kind of figuring the first equation out loud.
Okay, no, that's fine. It's just because you missed the first part of the lesson. So what you should do is the recording of this lesson will come out by tomorrow. And so what I would suggest is have a look at that recording, because from the beginning of the lesson, we were building up to this.
Yeah.
Cool.
Okay, thank you.
Pleasure. So this is a bit more tricky, eh? I'm turning up the heat here. Which of these matches the correct statement? And remember that if I want to use the cos rule, I need two sides at an included angle. So I think that this side is important, but I don't think the side of 11 is that important. I think, let me get this. So for me, these would be the two sides, that's sort of the arms that hold the thing together. And then here, this would be the included angle, which means that when I write it, it's going to be 11 squared is equal to that squared plus that squared. Oh, minus 2. And something. And then what is that something going to be? Well, I think there's going to be an x in there. There's going to be a 9. And then there's going to be a 44. So this is definitely harder than before. Which option do we think is going to fit that? Well, it can't be that one. Which one? I feel like this is missing a 2, so it can't be that one. So it's got to be either B or C. Which one do we think that is? This is definitely harder. I think that this is missing something. 2 times 11, there should be 2 times something. And so that can't be right. And so for me, the correct option would be that one. And you could even, it wouldn't be wrong. You could write this. I'm just kind of doing this for fun, but you could also write this as minus 18x times the cos of 44, because 2 times x times 9 would just give you this thing over here, the 18x. So that bit. Anyway, that was just a bonus. Give me a thumbs up, because that was much harder. Give me a thumbs up if you followed that now that I've explained it. Give me a thumbs down if you feel a bit lost by that one. The reason this was harder is that it kind of messed, the 11 drew your attention, but the 11 had to actually be by itself. So think about this. Whenever you write the cos rule, The thing that's going to always be by itself is going to be the side that is opposite the included angle. So maybe I should make a bigger deal about that. If you look at this 44, this is the angle that's included between the two sides. The one that is written by itself is opposite the angle that you're given. And that's something that's important to remember. It helps you know which one to write by itself if you're lost about where to write things. Okay, we're going to do another one like that. And so don't worry if you're feeling a bit confused, but I just want to point that out, that the bit that written by itself and squared is the one that's opposite the angle between the two other sides. Okay, let's find another one a bit like that if I can. Can I find another one like that? Nope. Okay, I'll tell you what, let's look at this one. Okay. Let's answer these two questions, just to make sure that we've got the right basic idea. So these are other statements of kind of a question that's partially completed. See if you can tell me in this question what goes in this block. For that one, and I'll call this question 1, and I'll call this question 2. So that one wants to know what's there, and this one wants to know what should be here. So tell me anything like 1A, 2B, or whatever it may be. Okay. So what we have here is we basically just need to put it into our calculators and see what we get. So let's go 5 squared plus 9 squared is 2 times 5 times 9 times cos 48. And I get 45.778 for that one, or B, so 1B. And what do we get for number 2? Well, I think that's just square rooting the original answer. So I'm going to go square root answer. And what do I get then? I think we get 6.7. So like this one over here. So actually it's 1B and 2B. Okay. So those are the second parts, but I think that's the easy part. The harder part is writing this down properly. So let me try and see if I can find you another question that flexes your brain a bit. Let's try and do this one together. Now, again, remember, I'm just teaching you how to use the cos rule in different ways. So which of the following would correctly calculate the value of x? So which of the following would correctly calculate the value of x? You tell me. Okay, so what I think you've realized is there's no ways that this can be a plus. This is just blatantly wrong, and that's blatantly wrong because there's no 90-degree angle, which you would need that. And so the correct option is really that's going to be A. So that's going to be the correct answer. Well done. Okay, well, let's see if I can find something. Let's do a combo question. So you have to find me two things now. We're going back to the previous lesson a little bit. You have to find me the length of YZ, which is this, but you also need to find me the area of this triangle. And I'll give you a little hint for the area rule. The area rule should have that structure, whereas the cos rule should have this structure. And I want to see if you can figure out those values for me. Oh, I hit the wrong button. Oopsie daisy. So find me the area of this triangle, and also find me the length of YZ. See if you can do that. It feels to me like this should be YZ. And this should be 8. Okay. What are we getting for our answers? Atule, let's go to your question. I see your hand is up. What is your question, Atule? How can I help? If you just look on the...
I have a problem from the second last question.
Yeah.
Let me go back.
Okay, let me see if I can scroll up or bring it back. So this one, is it this one over here you're talking about? The one that's further up there?
Yes, sir.
Okay, where did I lose you there?
Not this one, the other one.
Okay, let me first quickly finish this, and then I will do that one with you. I just want to quickly get the answers out for this, and then we can talk about where I lost you there. So for the area, we should have got 39,26. So 27 centimeters squared. And for the length of YZ, what are we going to get for that? Who has an idea of what we're going to get for the YZ value? And then I'll come back to you, Atule. Okay, so based on my calculator, I see we're getting 11.55 centimeters. So what I'm going to suggest here, if you could put the link to this week's quiz in the chat, we're pretty much finished with today's work, but I want to stay online and then answer questions from students who things they're unsure of from the lesson. But basically, you did very well today, and the main goal was to just learn how to use the cos rule to find sides. And what I want to remind you is that you're always looking for two sides in the included angle. Okay, so Atule, let's just check which question you were asking about. Let's have a look. Was it this one here, Atule?
Yes, yes. I'm not sure about how we got the answer for question 2.
Okay. What I did was I took the a squared equals this and I square rooted both sides. So if you put in your calculator the square root of 45.778, you should get this one over here. Does that make a bit of sense?
Yes, yes, I got it.
Perfect. Thank you for your question. That was great. So all I did was I just did this, basically. Okay. Are there any other questions or comments?